Good morning, children. Let's continue with our work. So, I will add the numbers that I have given you last week. Not last week, actually, it was on Wednesday. Okay, question number 58. Question number 58. Then question number 60. Then question number 61. Then question number 70. 76. 84. 85. 90, 103, and then 107. Then you have to move on with the projectile MCQs. Then you have to start projectile MCQs. In projectile motion, question number 1, 2, 6, 1, 2, 6, 9, 13, 14, 20, 30, and 32nd one. 30 and the 32nd one. Within the next week, when this weather problem is over, we have to write for the first paper, first term test practice paper. So be prepared. Now, after today, I'm not going to discuss more MCQs. Now it's up to you. You have to finish all these MCQ papers and then get ready. You have to face the first exam within this week. I will give you the exact days after these problems are solved, and when things become normal, I will give you the dates. So you have to come to the institute and write for these papers. Okay. Papers are set up to first paper. First paper is set using the questions up to relative velocity. That means the questions before Newton laws. Okay. So within this week, you have to write it. So be prepared. Okay. As a preparation, finish all these MCQs and get practice. Okay, and on this Thursday, we are doing Newton laws. We are starting the next lesson, Newton laws, on this Thursday as a private Zoom class. Okay, now let's finish these MCQs. Question number 58. Question number 58. Which of the following graphs represent the accelerated motion? Okay, these are the graphs. First one is a displacement time graph. Then the second one is also a displacement time graph. And the third one, here it's something like this. And the fourth one, it's a graph like this. Now, in these graphs, the first one, the time is passing, but the displacement does not increase or it does not decrease. let's say here the displacement value is 5. It does not increase, it does not decrease. While the time is passing, the displacement remains same. So what it means? The object is at rest at that position. Let's say we started to measure displacement from a certain point, point O. Now object is 5 meters right side from O. So its displacement is plus 5. Now it does not change. That means always the object is there without moving. So it's not accelerated motion. This is when the object is at rest. This graph shows an object at rest. Okay. Here in a displacement time curve, the gradient represent the velocity. So this is a constant gradient. So this is a constant velocity. Okay. Here the gradient is positive and it's increasing. So the velocity, the displacement time curve, the gradient is the velocity. Velocity is positive and it's increasing. Positive velocity increasing. It's acceleration. This is the accelerated motion. Here, initially, the displacement does not change. Object is at rest. Later, there's a straight line with the inclination like this. So this is a minus constant gradient. This minus constant gradient means the minus constant velocity. So it minus means object has turned back and coming to the other direction. It's in the opposite direction where the velocity is positive. So it's in a motion to a direction where velocity is negative. So that's why the gradient is negative in a constant value. That means the velocity is constant. So it's also not accelerated motion, even this part also. Here it's initially it's at rest. So this is also not the thing we are finding for. So here, this is the one. So the correct answer is answer C. Answer C. This is the place where you can see a acceleration through this displacement time curve. Okay, let's continue. Then question number 60. Question number 60. Okay, Pute, I got your message. I will do the question number 44 also. Last week, we got stuck. Our internet connection got stuck when we are in question number 44. Definitely, I will do that. Okay. Question number 60. Question number 60. The position time graph of an object moving in a straight line is shown below. The object has 0 velocity at. So, they say this is the position time graph. Let's see what this position time means. So, this is the nature of the graph. In this graph, they have given some point C, point D, point F, and here we have the origin. Okay. The position time graph of an object moving in a straight line is shown below. The object has 0 velocity at. When they say position time graph, what is the position? In Sinhala, it's PHT. PHT, the location the object currently presents. Okay. So what is the position time graph? So it might be a displacement time graph if the object is moving in a straight line. If the object is not moving in a straight line, the position means the distance might be the distance, how the distance varies. Okay, no problem. Whatever, if you are to find the gradient, if we go to find the gradient of a graph, whatever the graph, let's say here the x-axis and here the y-axis. If you are going to find the gradient of a graph, you have to draw this tangent and take the theta value here. So gradient is the tan theta. Okay, to take tan theta, opposite leg. Opposite leg will provide the difference in the y coordinate, and the adjacent leg will give you the details about the x coordinate. So the gradient is delta y over delta x. So here the gradient, whatever the graph, the gradient is delta y over delta x. That's the type. So here the gradient is delta y, the difference in the position over time. So no need to worry. Position over time. The position is measured by meters and the time is by seconds. Meters per second. So what do you mean by that? So this is a displacement, the position. So this graph, this is a displacement time graph. If we consider that this object is moving in a straight line, let's consider that this object is moving in a straight line, then this position time graph means simply the displacement time graph. And if the object is not moving in a straight line, this might be not a displacement time graph, it's a distance time graph. When this direction changes, it's not the displacement, it's the distance. So then this position time graph will be a distance time graph. But here they ask you about the velocity. That hints this was a displacement time graph. Only velocity is only provided through a displacement time graph. So they asked you about the velocity. So as they are asking the velocity, so this position time graph definitely is a displacement time graph. Okay. So in questions, these kind of things happen. Sometimes they change the words and they ask you the questions and they make you think of these special words without answering the question first. So that's okay. That's how the exams are. You have to face that. So little by little, you have to get practice with these kind of questions. So it's a position time graph as they say, but this position time means it's a displacement time over distance time graph. So here, as they ask you the velocity, okay, it's a displacement time graph. And whatever the graph, the gradient is the delta y over delta x value. So here the position over time value. So it's the velocity. As they ask the velocity here, as this gradient should be the velocity, to gradient be the velocity, position is the displacement. So this is the displacement time graph. Okay. Now in a displacement time graph, I'm changing this axis to SN. In a displacement time graph, the gradient is giving you the velocity. Here at this position, the graph has a certain gradient. This is the positive x-axis, there's an angle, and that angle will have a tangent. Okay, so there's a gradient. In this place also there's a gradient. This is the positive x-axis, and here you have a angle, and that angle will provide a tangent, and that tangent is the gradient. But in position D, if you draw a tangent to position D, actually the graph lies in the positive x-axis at that direction. In this certain instant, at this position, at this place, what happens to the graph? The graph also moving parallel with the positive x-axis, and here the angle created with the positive x-axis is 0. So this will give you a 0 value for tan theta, and the gradient will be 0. So the velocity will be 0. So the 0 velocity is indicated from the position that they have marked D. At this time, at this certain time, the object's velocity is 0 for an instant. not for a long time, for instant. As soon as with the time it changes and it gets a gradient value, that means it's having a velocity. But in this position, the object will be on a instantaneous rest, zero velocity. Okay, the answer is D. Then question number 61. Question number 61. The graph below shows a velocity versus time graph of a body. So in question number 61, it's a velocity time graph with the time, how the velocity changes. So this is the velocity time graph according to them. Which of the following graphs represent the corresponding acceleration versus time graph? Now we have to draw the acceleration time graph for this velocity time graph. You have to draw the acceleration time graph for this velocity time graph. Okay. So how to do that? The gradient of a velocity time graph will give you the acceleration. So here it's a minus constant gradient. Here this is straight line. If the graph is a straight line, it will give a constant gradient. If it's a straight line creating an acute angle with the positive x, it's a constant gradient with a positive value. If the graph is creating an obtuse angle with the positive x and it's a straight line, then it's a constant negative gradient graph. So this is m constant and it's positive. I'm sorry, this is m constant and it's negative, creating a obtuse angle with the positive x-axis. And here, this one, creating a acute angle with the positive x-axis, creating an acute angle with the positive x-axis, and it's a constant gradient graph as it's a straight line, and as it's creating an acute angle, the tangent will be a positive value, so the gradient is positive. The gradient gives you the acceleration, so this minus constant gradient will give you the minus constant acceleration, and instantly what happened? The next one is a positive constant gradient, so it's a positive constant acceleration. So this is how it has to be. So the answer is B. Answer is B. Okay. Now move to question number 70. Question number 70. As soon as you finish this tune, go for the projectiles tune, and then I think you can use today and complete all these MCQs. I think there are more than 250 MCQs. We counted that day. As I remember, there were more than 250. Let's say 250. Then finish them all, and it will be a great help for you for your exam within next week. Within the next week, you have to face the first exam. So be prepared. Okay, question number 70. A particle thrown down from a top of a tower takes time t1 to reach the ground. It takes time t2 if thrown from the same point with the same speed in the upward direction. The time it will take to fall freely to ground from the top of the tower is. That's a good question. Now there's a tower. Let's say the height of the tower is h. This is a good one. The height of the tower is h, and I will need more free space. Later. Now, so this is a tower with a height h. This is a location with a height h. Initially, from this height, a particle is thrown down from top of a tower. Okay, thrown down. It has an initial velocity. It's not zero, u. Thrown down from top of a tower. And it comes to the ground. It will hit the ground after time t1. It will hit the ground after time t1. The next case, from the same height, now it is projected upwards. They project it upwards with the same velocity u. So initially it will move upward. After the highest point, it will turn back and then it will come to ground and it will hit the ground. If this is the case, the time taken to hit the ground is t2. Time taken to hit the ground is t2. The time it will take to fall freely to the ground from the top. Now what they ask, at the third case, the height is the same one. Now it is not thrown, it is released with a zero velocity. So what is the time that it will take to reach the ground? What is the time that it will take to reach the ground? Okay. ඉතින් මම තාම වගකීමෙන් කියනවා මම දැන් මේක දැනගෙන කියන්නේ. හරි. ගම්පහ විතරක් නෙමෙයි බොහෝ විට ලංකාවෙම වෙන්නත් පුළුවන් හොඳම ගණන් ටික හදන්නේ අපි. හරි. ගම්පහ විතරක් නෙමෙයි බොහෝ විට ලංකාවෙම වෙන්නත් පුළුවන් ඉංග්‍රීසි මීඩියම් ක්ලාස් එකක හොඳම ගණන් ටික හදන්නේ අපි. يعني මට ලොකු විශ්වාසයක් තියෙනවා මම බොහොම බලලා දැනගෙන තමයි මේ ගැන කියන්නේ. හරි. හරියට වැඩේ කරගන්න ඒකක් අරගන්න ඔයාලට අවශ්‍ය පාර මේකයි ආ. හරි. Okay. Now, to find the time taken to reach the ground when the object is released from that height, definitely you need to find the height. To take an answer for this question, to find the time where it reaches the ground, when it reaches the ground, to find the time when it's released from rest, you need to know this height. So I think two initial situations will help you to find an answer for h. This h will help you to take the time to reach this point. So initially it is thrown downward with the initial velocity and it will come a distance h downward with the time t1. Then from the same height it is thrown upward with the same velocity. So initially it will move upward and then it will come back and hit the ground after time t2. Okay, and these facts will help you to find the answer for this h. That h, the answer for that h will help you to find the capital T value in terms of simple t1 and t2. Okay, so I am applying. I need to have an answer for this h. Okay, I am applying whatever the equation I'm applying, I don't need to know this final velocity. Let's say it is V1 here. Let's say it's V2. Here it's V3. I don't know whether they are same or not. But whatever the situation, I know one thing. Try introducing these final velocities will not do any good. Okay? Introducing these final velocities for our equations won't do anything. No need. So thought of applying an equation where the final velocity is not present. So what is the equation where the final velocity is not present? It's s equals ut plus half at square. It's s equals ut plus half at square. Okay. Then for this s equals ut plus half at square equation, the distance it has to come down is h. Initial velocity is u, time taken is t1 plus half when an object is released from a higher point and it's coming downward throughout its motion, acceleration of gravity is plus g t1 square. Okay, then again I'm applying s equals ut plus half at square, applying s equals ut plus half at square. Initially I applied it downwards as the object is coming downwards from the beginning. But here object moves upward first, it will turn back and come down after the highest point. So it's something else. Applying s equals ut plus half at square upwards. Okay. Now initially it moves up, that's correct. But after the maximum height, it comes back. So the displacement is not the distance that it travels. Displacement is the gap between the initial and final points. So it's h. But as we're applying the equation upwards, now the final displacement is in the downward manner. So it's minus h here. It's minus h. So this is the distance that it travels. This is the distance that it travels. Displacement is the gap. So it is the h again. But it's you are using the equation upward. So the gap is in the final gap is in the other side. So it's minus h is equal to initial velocity upward. So it's plus u t2 plus when an object is projected vertically upward from a certain position, it's minus g t2 square. So here I have h is equal to ut1 plus half gt1 square minus h is equal to ut plus half minus g t2 square. This is the second equation I got. Okay. Then here if I apply s equals ut plus half at square downwards to this equation, to this situation, what will happen? Object has to come a displacement h in the downward manner. I am applying s equals ut plus half at square downwards. So the distance it has to travel downward, the displacement it has to travel downwards is h. Now it's not thrown. Initial velocity is 0, ut multiplication will be 0 plus half and the acceleration of gravity is plus g. Acceleration of gravity is plus g, positive, when it starts from a higher point and coming downwards, g t square. I'm saying it capital T. So h is equal to g over 2 capital T square. If I know if I know h in terms of t1 and t2, my problem is solved. Why? I need to find capital T. To find capital T, acceleration of gravity is okay, it's everywhere and it will cancel out. So I have to find some way to replace h. Okay, now I have to make h from these two equations and substitute it here. That's my plan. To do that, there's another little obstacle I have to face. Here, can you see there's the initial velocity ut1. Here, again, you have the initial velocity u. But initial velocity value u is a symbol that I introduced. It is not in the question. So I can't take u to this side. So using these first two equations, I had to do something to eliminate u. After I eliminate u, then I have to subject h and substitute that h to this place. So this is my plan. Okay. To eliminate u, what can I do here? H minus g over 2 t1 square, h minus g over 2 t1 square over t1. I'm subjecting u. H minus g over 2 t1 square, it will be ut1. This value will be ut1. So t1 will be h minus g over 2 t1 square over t1 will be u, subjected u. Again, I am subjecting u from this place also, minus h, taking this term to the left side. So this minus mark will become plus g over 2 t2 square minus h minus g over 2 t2 square is equal to ut2, then minus h g over 2 t2 square over t2 will be the answer for u. Now you have two answers for u. It's the same velocity. Now you can equal these two terms that you got for u and eliminate u. Okay. Now I'm going to erase this part. Okay, here u is equal to h minus g over 2 t1 square over t1. It's the answer for u. It's the same velocity that they used in the second case also. So again the u value, I'm equaling them. Minus h plus g over 2 t2 square over t2. Now I have an equation where I can subject h. To do that, initially I am cross multiplying them. H shall I do like this? Here I have a division. So h over t1 minus g over 2 t1 square over t1, h over t1 g over 2 t1 square over t1 is equal to minus h over t2 plus g over 2 t2 square over t2. So I have a complete division here, dividing h over t1 and minus g over 2 t1 square by t1. This will do the job. Dividing minus h from t2, dividing g over 2 t2 square from t2. Okay, now I need to erase this. Then what will happen? H over t1 here minus h over t2, I'm taking it to this side. Then it will become plus h over t2 h over t1 minus h over t2, I'll take it to this side, plus h over t2. Here 1t will cancel out, g over 2 t2, and here 1t1 will cancel out, and this minus mark will become plus. We're not taking to the other side, plus g over 2 t1. H over t1, this minus h over t2 will become plus h over t2 in this side. G over 2 t1 will be moved to the other side with the positive side, and there you have g t2 over 2. And then what you can do? Take h outside, 1 over t1 plus 1 over t2. Take g over 2 outside, t2 plus t1. Okay. H here, t1 t2, t1 plus t2. G over 2 here, t2 plus t1 or t1 plus t2 same, and it will cancel out. Here took h outside, 1 over t1 plus 1 over t2, t1 t2 over t1 plus t2 over t1 t2, 1 over t1 plus 1 over t2, t1 t2 is a common factor, and then here t1 plus t2. G over 2 t2 plus t1 means simply t1 plus t2, and this will cancel out. So now I got the answer for h. Cross multiplying t1 t2, t1 t2 g over 2. Now the h value is t1 t2, this one to this side, g over 2. Now finally, from using the initial facts, there were two initial facts. One was when the object is thrown downward with a velocity, with a certain velocity, it reached the ground after time t1 passing a height h in downward manner. In the same height, now the object is projected upward. It will initially move for a certain maximum height, then it will turn back and it will come to the ground. In that case, the total time is t2, but the total displacement is minus h. Okay, you wrote equation for these different cases. Then finally, by simplification, you got the answer for the height that these stones were released. Now you know the height. Then what can you do? As you know the height, you can come to the place where the question lies. Now they say object is released, that means with a zero velocity, and it has to pass the same height. So you apply the equations. S equals ut plus half at square. There the initial velocity is 0. So the h is equal to gt square over 2. Now you are almost there. H is equal to t1 t2 g over 2. This h, now you can substitute. H is equal to t1 t2 t2 g over 2. H is equal to t1 t2 g over 2 is equal to g over 2 capital T square. G over 2 will cancel out. Capital T is equal to root t1 t2. Got the answer. It's a very good question. Huh? These kind of questions will help you to develop your brain power. T is equal to t1, the root value of t1 t2. Answer is B. Answer is B. The next question, question number 76. Question number 76. Now these are the homeworks that you have to pay your attention. You have to finish these MCQs and study whatever you study and get ready for the exam. The first exam is up to relative velocity. The next thing, you have to prepare for the Zoom class on Thursday. And there we have to start Newton laws. It's a very important lesson. So you all have to join. Huh? I'm checking whether you have joined or not. So definitely you have to join. It's on Thursday. Question number 76. So these are the graphs. සර් නිකන් වැහලා නෑ වගේනේ හැසිරෙන්නේ. සර් වැහලා නෑ වගේනේ හැසිරෙන්නේ. වැස්ස ගැන කියන්නේ වැස්ස හින්දා වැඩ නවත්තන්නේ. වෙන කොහේ හරි පැත්තකදී මේ ඔයාලා සර්ලා පැත්තට වහින්නේ නැද්ද? ඒ වගේ ප්‍රශ්නක් තියෙන්න පුළුවන්. වැස්ස ගැන කිසිම කන්සර්න් එකක් නෑනේ මේ මිනිස්සයාගේ. මේ කතාවක් කියන්නද? වැස්සෙන් වෙච්ච සිද්ධියක් හින්දා විශ්වාස කරනවද මම සෙරෙප්පු දෙකක් නැතුව ගම්පහ ඉඳලා ගෙදර ආවා කියලා බස් එකේ. ළඟ කාලෙක බස් එකේ ගිහිල්ලත් නැහැ. ලැජ්ජයි. සෙරෙප්පු දෙකක් දාන්න නැතුව බස් එකේ ආවා කියලා දන්නවද? සෙරෙප්පු දෙකක් නැති වෙලා. හරිද? හැමදේම කිය ඉන්න ඕනේ නැහැ කරදර. වැඩේ කරන්නයි තියෙන්නේ. ළඟදී බස් එකේ ගිහිල්ලත් නැහැ. සෙරෙප්පු දෙකක් නැතුව බස් එකේ ආවා. හරි මට ඒක නිකන් ඉරිටේටින් නේ. හරි දැන් මට නිශ්ශබ්දවම ඉඳලා තිබුණා මුල්ලකට වෙලා. මට අර විලි ලැජ්ජයි සෙරෙප්පු දෙක නැතුව. එහෙනම් මම මට කන්ඩක්ටර් කිව්වා ඇතුළට යන්න කියලා. මං කිව්වා සෙරෙප්පු දෙකක් නැහැ මට යන්න ලැජ්ජයි කියලා. ඒ උටත් හිනා. හරිද? එන්න වැස්සෙන් වෙන වැඩ. එතකොට වා කී ඉන්නලා තේරුමක් නැහැ. අපි ඉගෙන ගන්න වැඩේ කරන්න ඕනේ. හරි අමාරුකම් එනවා යනවා. තේරුණාද? හැබැයි කිසිම තේරුමක් නැහැ ඔයාට. හරි මේ දුක් වෙලා. අම්මා තාත්තා වුණත් හිතුවනම් සර් වැස්ස ගැන කිසි ගාණක් නැතුව වැඩ කරනවා කියලා. ඔය ඔහොම ඉන්න ගමන් කියන්න ගිහිල්ලා. සර් ගම්පහ ඉඳලා සෙරෙප්පු දෙකක් නැතුව බස් එකේ ඇවිල්ලා කියලා. බස් එකේ ගිහිල්ලත් නෑ අවුරුදු ගාණකින්. අන්තිමට සෙරෙප්පු දෙකක් නැතුව බස් එකේ ඇවිල්ලා. හරි වැස්සේ ප්‍රශ්නෙට කියලා. හරි වෙච්ච කරදරේ තව දිගට යනවා කතාව කියන්නේ කිව්වොත් කොහොමද සෙරෙප්පු දෙකක් නැතුව ආවේ කියලා. හරි මොකද්ද උනේ කියලා. හරි ඉතින් මේ වැඩක් නැහැ. තේරුණා නේද? දැන් මේ කතාව ඉවරයි. වැඩක් නැහැ. වහී පායයි. හරි හැබැයි අපි ජීවත්ව ඉන්නවා නම් මැරිලා නැත්තම් කතාව ඉවර නැහැ. මතක තියාගන්න ඒක. අපි තාම පණ පිටින් ඉන්නවා නම් පරාජය වෙලා නැහැ. හරි කරන්න තියෙන්නේ ෆයිනල් ටාගට් එකට උත්සාහ කරන එක. එතනදී මගදී දකින්න දේවල් ගැන වැඩිය පද වෙන්න එපා. කර යුතු එකම දෙයයි තියෙන්නේ හරි අසරණ වෙච්ච කරදර වෙච්ච මිනිස්සුන්ට උදව් කරන එක විතරයි. තමන්ගේ කරදර තමන්ට වෙන දේවල් ගණන් ගන්න එපා. හැබැයි ඒක තව මිනිස්සෙකුට වෙනවා නම් එයාට උදව් කරන්න පසුබට වෙන්නත් එපා. නමුත් මේ වෙලාවේ හරි පුතා ඉන්නේ මිනිස්සුන්ට උදව් කරන්න පුළුවන් තැනක නෙමෙයි. මේ වෙලාවේ ඔයා ඉන්නේ ඉස්සෙල්ලා ඔයාටයි ඔයාගේ දෙමව්පියන්ටයි උදව් කරන්න ඕනේ තැනක. ඒ කියන්නේ ඉගෙන ගන්න ඕනේ තැනක. ඔයා හොඳට ඉගෙන ගත්තොත් තමයි කවදා හරි දවසක ඔයාට අනාගතේ මේ වගේ කරදරයක් වෙච්චහම මිනිස්සුන්ට දැනෙන උදව්වක් කරන්න පුළුවන් තත්ත්වයට හරි ඔයා නිදහස් වෙන්නේ. නේද? ඒ නිසා මේ වෙලාවේ මගේ ඩියුටි එක ඔයාට හොඳින් උගන්වන්න එක. හරි? නැතුව මට වැස්ස කරදර නැතුව හැම නෙමෙයි. හරිද? ඒක හරි. එදා මං හිතන්නේ එක ළමෙක් විස්තරය දන්නවා. එදා ඉන්ටර්නෙට් කනෙක්ෂන් එක ගියානේ. ඒ වෙලාවේ මෙතන කුණාටුවක් හැමුවා. පොඩි කුණාටුවක්. තද හුලඟක් ආවා. හරි? ඉතින් ඒක තමයි ඉන්ටර්නෙට් කනෙක්ෂන් එක අන්ස්ටේබල් උනේ. හරි. ඉතින් ඒකට මම කියන්නවත් වෙලාව ගත්තේ නැහැ. හරි. දැන් අද උදේ තේ જાතිය වැඩක් වුණා. හොස්පිටල් එකට එහෙම යන්න එන්න වෙනවා නේද? මේ ડોක්ටර්ස්ලාට ගෙදර ඉන්න බෑනේ. ඉතින් වයිෆ් වැඩ එකත් එක තමයි අද උදේ අපි සටනක් කළේ. හරි. ඒවා එකක්වත් අවශ්‍ය කාරණා නෙමේ, අවශ්‍ය දේ වැඩේ කරන එක. හරි. ඔන්න ඒ වැස්ස ගැන කතාව එතන විනාඩි පොඩි ගානකින් ඉවරයි. හරි. හැබැයි ඔයා අනාගතයේ දවසක ඔයාට එන බාධක අනාගතයේ නෙමේ අද ඉඳන්. ඔයාට එන බාධක දශමයකටවත් ගණන් ගන්න එපා. හැබැයි වෙන මිනිස්සෙකුට බාධාවක් කරදරයක් ඇවිල්ලා නම් ඒ මිනිස්සයාට උදව් කරන්න පැකිලෙන්නත් එපා. ඉතින් ඒක කරන්න පුළුවන් තැනක නෙමෙයි ඔයා මේ වෙලාවේ ඉන්නේ. අනාගතේ හරි ඔයා හොඳින් මේ වගේ තැනකදී මිනිස්සුන්ට උදව් කරන්න නම් අද හොඳින් ඉගෙන ගන්න. හරි වැඩේ යන්න. Hari. In this question number 76, which of the following graphs represent the displacement time graph for uniform motion? Okay. So which of the following graphs represent the displacement time graph for uniform motion? Now, what do you mean by the uniform motion? Sometimes it might be a uniform, constant velocity. Sometimes it might be a constant acceleration. So we are not clear what this uniform motion stands for. So we have to check through the answers. Okay. Let's see. Here it's a constant gradient and gradient is positive. Displacement time graph, the gradient gives you the velocity. Okay, gradient gives you the velocity. So it's a constant positive velocity. Here gradient is positive and increasing. Here the gradient is positive and increasing. So the positive increasing gradient means the velocity is positive and it's increasing. It's acceleration. This is a constant velocity. Here initially gradient is a positive constant. So the velocity is a positive constant. Then the gradient is a negative constant. So the velocity is a negative constant. Here initially the gradient is positive decreasing, velocity positive decreasing, then gradient negative increasing. This part you have to short note. Then velocity negative increasing. So this is a constant velocity. So it's also a uniform motion. It's a uniform constant velocity. So this is the acceleration. So I'm leaving this one. This is not the case they asked. This is acceleration. Yes, there's a term called uniform acceleration. So you might doubt that whether they are asking for the uniform acceleration. But can you remember there's a limit in the displacement time curve? Through a displacement time curve, you can identify whether it's acceleration or not. But you can't identify whether the acceleration is uniform or not. That's a limit. In a displacement time curve, the gradient will give you the velocity. If it is an increasing gradient, it will give you the increasing velocity situation. That means the acceleration. It will represent the acceleration. Okay. So this is acceleration. But can you remember the limit? Through a displacement time curve, you can't judge whether the acceleration is constant or not. Through the gradient, you can find if the gradient is increasing, the velocity is increasing. That hints the acceleration. But there's no any exact method to confirm whether the acceleration is uniform or not through a displacement time curve. So they are asking for the uniform motion. So definitely this will not provide any answer. Why? When it says a uniform motion, we have a certain doubt whether they are asking about a uniform acceleration or a uniform velocity. We have that doubt. Whatever the doubt, this is not giving us an answer. Why? Through a displacement time curve, we can't judge the acceleration whether it's uniform or not. We can't judge that. So I'm leaving it. There's acceleration, but I can't judge whether it's uniform or not using a displacement time curve. So this is not the answer. Here what has happened? Here initially the velocity is a constant value and then the gradient is a constant, then suddenly the gradient is a negative constant. What do you mean by that? It has changed the direction. Velocity suddenly becomes negative. That means inside the motion there's a point where the object turns back. So it's also not a uniform motion. Moves in one side and then comes to the other side. So I'm leaving this answer. Can you understand the weight of this question? They're asking you the uniform motion. So the second answer gives you a acceleration. So I doubted whether this is a uniform acceleration that they're asking us. But I leave that doubt. Why? Through the second curve, I can't decide whether the acceleration is uniform or not. So it will not be an answer. In the third and fourth, let's say the third one, in the third curve, what's there? There's a constant velocity, constant positive gradient, and then there's a constant negative gradient. That means initially object moves in a certain direction. Velocity is a positive constant. Then velocity becomes a negative constant. Velocity becomes negative means it turns back. So it's also not a uniform motion. Why? It turns back. So I leave that answer. In the third one, what happens? Here, initially it's positive decreasing gradient, then positive negative increasing gradient. So positive decreasing velocity, then negative increasing velocity. So one thing is velocity change from plus to minus. That means object turns back. Then also it is not uniform according to this question. According to this question, that situation is also not uniform. And the other one, we don't know that there are velocity changes, initially positive decreasing, then negative increasing. There are accelerations. If they are asking about the uniform acceleration as our previous doubt, but even though we can't have an answer from this part also. Why? We don't know the acceleration is uniform or not by looking at the displacement time curve. So I'm leaving all these doubts and I'm going to select the first answer. I'm going to select the first answer. Why? First answer is a simple constant velocity. So they might be asking for the constant uniform velocity. So this is a simple constant velocity in a certain direction. It does not change the direction also. So this is the most suitable answer. Most suitable answer. Question for the question. It's just a constant velocity in a certain direction. So it's a uniform motion. Here this uniform, this word has a higher weight. Okay, the first answer, the object has a constant velocity to a certain direction. It's not changing even. The direction is also not changed like in the third one. So it's a pure uniform motion. I'm selecting it as the answer. Okay, then question number 84. Question number 84. The velocity time graph of a body moving in a straight line is shown in the figure. Now it's a velocity time graph. Okay, in this velocity time graph, plus 4 until the time is 2 seconds. Then suddenly velocity changes to a value minus 2. It lasts for another 2 seconds until the complete time is 4. Then the velocity suddenly changes to a value plus 2. There are sudden instantaneous changes in the velocity. This is not practical with the real world vehicle. And that velocity value remains up to the 6th second. Okay. The velocity time graph of a body moving in a straight line is shown in the figure. The displacement and distance traveled by the body in 6 seconds are respective. Initially, you have to find the total displacement and the distance. In a velocity time graph, area under the curve will give you the displacement. Here, I'm going to find the areas under these certain places. This is A1, this is A2, this is A3. Okay, let's find A1. It's a rectangle. Height is 4 and the width is 2. 8 meters. A2, height is 2. Height or the width or whatever. The other side is also 2. 4 meters. A3, 2 into 2. 6 minus 4, it's also 2. 4 meters. So shall I draw the motion? Initially, it's a area under positive velocity. If the area is under the positive velocity, it's the normal displacement. And the object got a displacement of 80 meters, 8 meters. Then, if the area under the curve, is from the negative side, it gives you the distance that the object came back. It gives you the distance that the object came back after turning. How do you know that it turns? Velocity suddenly become negative means it is in the opposite direction now. That means it has turned. After turning, the distance that it comes to the initial side, it is the area under the curve for this minus velocities. So it's 4. That means after 8 meters, it's coming back for another 4 meters from this side. And it will come to here. Now it's here. Then again, the graph moves to a positive velocity. That means again the velocity became positive means it turned back again and now it has the initial direction where the velocity is positive. Now again it's moving and to that distance, to that direction, the displacement or the distance that it travels is the area under this A3 part. It's 4. It turned again and moved to this side. Now it is here. So what is the distance? Distance is the length of the route. 8, 4, 4, 16. But what is the displacement? What is the displacement? It is the gap between it's the linear gap between the initial and final points. So it's 8 meters. From here to here it was 8, came another 4, but again moved the 4 meter value again to the initial side. So the gap between the initial and final positions, it's 8 meters. So the displacement is 8. So what is the answer? the displacement and distance. Displacement is 8, distance is 60. Okay, move to the question number 85. Move to the question number 85. In the following velocity time graph, the distance traveled by the body in meters. Okay. So in a velocity time graph, now you know the area under the curve will give you the displacement. And if it is in a straight line, that's why the velocity is being defined and the distance and the displacement are same for a straight line when moving in a certain direction. Here, there are no negative velocities. That means it hasn't turned back. All are positive velocities. That means it's in a certain direction, not coming back. And again, and the velocities are introduced. That means it's definitely in a straight line. So this is a motion. It happens in a straight line to a certain direction. In such a case, displacement and the distance are same. So calculate the area under the curve and find the displacement. It is the distance that the object travels. So it's a trapezium. It's a trapezium. So what are the length of these parallel legs? 20 minus 10 plus 30 minus 0. Length of the parallel legs added divided by 2 and you have to multiply it by the perpendicular height. It's 10. It's 10. 20 minus 10, it's 10 plus 30 over 2 into 10. 40, 20, 200 meters. It's a simple question. The answer is A. Okay. Now come to the 90th question. 90th question. Hope you have finished trying all these questions and now you are in the projectile motion MCQs. Continue. Question number 90. A body starts from rest with a uniform acceleration. If its velocity after n seconds is v, then its displacement in the last 2 seconds is. Draw a small diagram. Body, it starts from rest. Its initial velocity is 0. With a uniform acceleration, it will be moving with a uniform acceleration. So you can apply the equations of motion. If its velocity after n seconds is v, initially time is 0. When the time is equal to n, after n seconds, its velocity is v. Then its displacement in the last 2 seconds is. Its displacement in the last 2 seconds is. Okay. Now its final velocity is v after n seconds. Before 2 seconds, that means that the time is n minus 2. It started from where we started to measure the time. That's the point where we started to measure the time t equals 0. Now it has moved to a certain distance, a displacement after time t. If we need to take out the time 2 seconds earlier to this final situation, it's the time where t is equal to n minus 2. It started from a time 0 where we start to measure time, and now it has moved up to a time where t is equal to n and gain a velocity v. If we need to take out that certain situation, that certain instant, 2 seconds before this velocity v, then the time passed is equal to n minus 2. And what they ask? They ask you the displacement in this last 2 seconds. This displacement value, let's say x, this. I'm applying s equals ut plus half a t square. I'm applying s equals ut plus half a t square for n seconds from the beginning. The displacement throughout the motion, I can say it as s s2, let's say sn. From the beginning up to the nth second, the displacement is sn. Sn is equal to initial velocity 0, ut multiplication 0, half a n square. The total displacement after the nth second is u is 0, initial velocity, so ut multiplication 0, half a n square sn. Again, I'm calculating the distance traveled up to this point, up to t equals n minus 2. It's Sn minus 1 from symbol. Through my symbols, it's Sn minus 1, Sn minus 2. Initial velocity is 0, so no need to worry about this ut term, but this half a t square remains. Half a time is n minus 2 from beginning up to this point, n minus 2 square. Then I'm subtracting Sn minus 2 from Sn. Why? From the beginning, the complete displacement is Sn up to nth second. 2 seconds prior to the nth second, from this side, the complete displacement is Sn minus 2. I'm subtracting them, and then the answer I will get is the value x that they ask, the displacement in the final 2 seconds before reaching this place. So x is equal to half a n square minus half a n minus 2 square. Half a n square minus half a n minus 2 square. So x is equal to half a n square minus n minus 2 square. X is equal to half a n square minus n minus 2 square. N square minus 4n plus 4. N minus 2 complete square, n square minus 4n plus 4. So x is equal to a over 2 n square minus n square plus 4n minus 4. So x is equal to a over 2 4n minus 4. X is equal to a over 2 4n minus 4. Okay, now you have an answer for x, but here's the Here there's a problem. You have A, but simply know, V equals U plus AT up to nth second. You can apply V equals U plus AT up to nth second. After the nth second, at the nth second, velocity is V. Initial velocity is 0. A time is n. V is equal to A. So, A is equal to V over n. You can substitute it here. X, the displacement within the final 2 seconds. I took the displacement up to the nth second from beginning. As I was applying equations from beginning, initial velocity was 0, then the ut multiplication is 0. So I got the answer for Sn. Then I applied S equals ut plus half at square from beginning up to the n minus 2 seconds time period. Then what happened? I got the answer Sn minus 2. By subtracting them, I got the displacement that this object gains within the last 2 seconds. There, I had the symbol A. The acceleration symbol was there, but it's a symbol which was introduced by myself. It's not in the final answer. So thought of a substitution for A. Applied V equals U plus AT from beginning up to the nth second. Then the velocity is V is equal to 0 plus A n. The time is n when the velocity is V. Okay, from there I got A is equal to V over n. Now X is equal to A over 2. Took 4 outside, n minus 1. A is equal to V over n. 4 over 2 will give you a value 2 here. A is equal to V over n. Here 2. N minus 1. X is equal to 2V n minus 1 over n. X is equal to 2V n minus 1 over n. 2V n minus 1 over n. Answer is A. Answer is A. Then question number 103. Question number 103. I'm taking a small rest. I'm here. Okay, you can continue. Question number 103. Then question 107. Then move to projectiles. Question number 103. A rubber ball is dropped from a height of 5 meters on a planet where the acceleration due to gravity is not known. A rubber ball is dropped. So its initial velocity is 0. It's not thrown. It's not thrown. Initial velocity is 0. It comes toward the ground. It will hit the ground. It will hit the ground. H is 5. On the bouncing, it rises to 1.8 meters. After it hits the ground, it will bounce back and it will move to a certain height and will turn back again. So in this case, initial height is 5 meters, but now it rises to a distance of 1.8. The ball loses its velocity on bouncing by a factor of. Okay. Initial velocity is 0. It's 5 meters and it will come and hit the ground with the velocity v1. When hitting the ground, it will lose some of its velocity. It will change the direction also. And when it hits the ground, some of its energy is destroyed. Destroyed means it's turned into heat, sound, and other things. So what happens? The remaining kinetic energy will be lesser than the kinetic energy where it hits the ground. So what will happen? The bouncing velocity will be a lesser value, v2. With that bouncing velocity, it will reach a height and will turn back again. It will not reach the same height. Why? When it hits the ground, some of its kinetic energy was lost. So now the remaining energy will give a lesser velocity where it can't reach the height where it came from. So this is the situation. Initially dropped from a 5 meter height, it comes to the ground and hits the ground with a certain velocity, and some of its kinetic energy will turn to heat, sound, and other things and will be absorbed by the earth. So it will have a lesser kinetic energy value with a lesser bouncing velocity. So it will move to a certain height but not the instant height, and it will come back. So this is the situation. I'm applying V equals U plus AT for the downward motion. I'm applying V equals U plus AT for the downward motion. The velocity when it hits the ground is V1. Initially it was dropped, so it's 0. When an object starts from a higher point and coming towards ground, when it starts from a higher point and from the beginning, when it's coming from the towards ground, acceleration of gravity is plus g. I'm saying it g dash because this is not on earth. So I don't know the value for g. It's not 10, just the symbol g dash. It's not earth, so I don't know the value. It's g dash. Anyway, according to the sign convention, it's plus g dash. Why? From the beginning, objects comes towards the ground. So the final velocity v1 is equal to 0. It's dropped, initial velocity 0 plus g dash into time t here. But I think I didn't use the correct equation. Why? The facts, the data that they have given is the height 5 meter. So thought of applying v square equal to u square plus 2a again for the downward motion. The final velocity when it hits the ground is v1. v1 is square. Initially it was dropped 0 to g dash 5. v1 square is equal to initial velocity 0, u square plus 2as, 2, acceleration of gravity is unknown g dash, displacement 5. From the beginning, we are applying equation towards ground. So, in that case, acceleration of gravity is plus. So, the v dash is equal to root 10 g dash. The velocity that it hits the ground is equal to root 10 g dash. Then what happened? After hitting the ground, some of its kinetic energies turn into other kind of energies. Okay, so it lost the kinetic energy. Now its velocity is relatively small and it bounces back. And for this upward motion, I'm applying v square. V square is equal to u square plus 2as again. Okay, and it reached up to a 1.8 meter height. At the 1.8 meter height, its velocity will become 0 and it will turn back again. So in the upward motion, I'm applying v equals u square plus 2as up to the highest point. Okay, at the highest point, velocity is 0. Initial velocity that it bounces from ground is v2. At the highest point, its velocity is 0. The initial velocity that it bounces from ground is v2 plus when the motion is upward from ground, acceleration of gravity is minus g dash. We don't know the value. Anyway, it's minus. So minus g dash. The height when the velocity is 0 for instant, that means the maximum height is 1.8 when the velocity is 0. Here, velocity is 0 and it will turn back. Up to that level, the height is 1.8. So this minus g dash will become plus in the other side, 3.6. 3.6 g dash is equal to v2 square. So v2 will be root 3.6 g dash. Okay, what they asked, the ball loses its velocity on bouncing by a factor. They asked the factor that the ball loses its velocity. The factor that the ball loses its velocity. What is the fact? How to find the factor that the ball loses its velocity? After it's being bounced, its velocity is v2. It's v2. Okay. So initial velocity is that it hits the ground. The velocity that it hits the ground is v1. So the velocity change is v2 minus v1. It bounces back with the velocity v2. It hits the ground with the velocity v1. So the velocity difference is v2 minus v1. But to find the factor, the ratio that the ball loses its velocity, the difference divided by the initial value. This is what they ask. Remember that when the factor is being asked, the factor, if you are asked to find the factor that it changes, you have to find the change v2 minus v1 and divided the whole thing from the initial value. The factor, the ratio that it changes. So you have to take the change v2 minus v1 and you have to divide it by to find the factor divided by the initial value. So what they ask is v2 minus v1 over v1. v2 minus v1 over v1. Okay, v2 minus v1 over v1. What is v2? Root 3.6 g dash minus root 10 g dash over root 10 g dash. To find the factor that it changed, you have to find the change. Then you have to take the factor by dividing it by the initial value. G dash will cancel out. Root 3.6 minus root 10 over root 10. I can multiply both sides from the same value. 10 multiplied by root 3.6 minus 10. No use. No use. I'll take it by this way. Divided root 3.6 by root 10 and subtract root 10 divided by root 10. That will be a good method. Okay. Then the complete root here. 3.6 over 10 minus 1. So the factor root 3.6 over 10 minus 1. So the factor root 0.36 minus 1. Root of 0.36 is equal to 0.6 minus 1. So it's minus 0.4. Minus means the velocity has reduced. You know that. Due to the energy loss, velocity is reduced. The factor that the velocity reduces is equal to 0.4. The minus hints that the velocity value will reduce. Yeah, we know that. And the factor is 0.4. Point 4 means minus 2 over 5. Answer is A. Okay, let's move to question number 107. Let's move to question number 107. Question number 107. After question number 107, we are taking a small break. Okay, first we will do question number 107. Then we will discuss about the interval. Rocket is fired vertically upward from the ground. A rocket is fired vertically upward from the ground. It moves upward with a constant acceleration of 10 meters per second. for 30 seconds, after which the fuel is consumed. After what time from the instant of firing will the rocket attain its maximum height? Okay. Rocket is fired from ground and it moves with a constant acceleration of 10 meters per square second from t equals 0 to t equals 30. Then at this moment fuel ends. Fuel ends and from there you have to think what's going on here. No fuel. So will it move upwards? So you have to understand what the motion is first. First you have to understand the type of the motion. And finally you have to find what's the total time when it reaches the maximum height. What is the total time when it reaches the maximum height? Okay, so how to do that? Now here, what is the situation? What is the situation? Now, when a stone-like object, when a stone-like object is projected from ground, it doesn't have an engine. There's no any mechanism to burn fuel and activate a force that can accelerate the object. But in a rocket, in a stone, we just throw it upward, and from the beginning it is under the motion under gravity. Okay, when we take a stone, we just throw it upward. The only force acting on the stone is the weight, so its velocity is reduced from the beginning and faces the minus g value. But in rocket there's a mechanism to burn fuel and create a force upward, create a final force upward where the rocket can accelerate upward. So the motion of a rocket is not the type of the motion of a stone which was thrown vertically upward. The stone which was thrown vertically upward the only force that it faces is the gravitational pull. So from the beginning it will reduce its velocity under acceleration of minus 10. But there's a mechanism for a rocket to create a force upward that it can accelerate upward. So the motion of a rocket is not the motion under the gravity, it's a different one. So it has gained an acceleration of 10 meters per second. So what will be the velocity that it gained after 30 seconds? From t equals 0 to t equals 30 seconds. Applying v equals u plus at from t equals 0 to 30 seconds, applying v equals u plus at. So the velocity after 30 seconds, initial velocity is 0. Initial velocity is 0. Acceleration is plus 10. 30 seconds. The rocket will gain a 300 meters per second velocity when it's in 30th second of its motion. Okay, so first you have to understand that fact. the rocket is not in a motion, that it just faces the gravitational pull and faces the acceleration of gravity of -10. These were the stones which were projected upward, but rocket has a certain method to create a force upward through its engines and get the acceleration upward. So they have given that acceleration, it's +10. It's not a case of this motion under gravity. The weight is there, but there are additional forces which can create this acceleration. So I'm applying this acceleration +10 upward, and after 30 seconds, rocket has gained a velocity of 300 meters per second. But after that, what happens? At the 30th second of its motion, what happens? Fuel is over. Now, as the fuel is over, it can't burn fuel and create that additional force which helped the rocket to accelerate upward. So after from the 30th second, rocket is just same as a stone which was thrown upward. So after the 30th second, at the 30th second, rocket had gained a velocity equal to 300 meters per second. At the 30th second, but after the 30th second, it is same as a stone moving upward under the motion of gravity. After the 30th second, fuel is over. So this additional force which accelerated the rocket upward is no longer there. So only the weight. If the weight is the only force, it faces the motion under gravity situation, and from there its acceleration will become -10, and this velocity will reduce and it will reach its maximum height and then will turn back and drop down. Okay. From 30th second until the max height, applying V equals U plus AT. Okay, until the 30th second, fuel is there, it's burning, and this creating this additional force which the rocket was accelerated, which the rocket gains the acceleration, and it was accelerated for 30 seconds with a value of 10 upwards and got a velocity of 300 meters per second. After this, fuel is over, so this additional force is not there, so it's just an object which has the weight downward. So it will face the motion under gravity from there, and it will move to a distance. It will move for upward further. It will move upward for further until its velocity is 0 before drop down, before turning back and comes down like the previous stones we studied. Okay, so from velocity of 300 meters per second until it reaches the maximum height. At the maximum height, velocity is 0. Now it faces the motion under gravity with the acceleration of -10. And what is that t dash? 10 t dash equal to 300. T dash is equal to 30 seconds. T dash is equal to 30 seconds. Okay, so from beginning up to the from beginning until the 30th second, it had an acceleration of +10 due to the fuel burning process and the force created, and it gained velocity of 300 meters per second, and from there the fuel is over, and now the only force is the weight. If only force is weight, it's the motion under gravity, and from there it faces the acceleration of gravity of -10, and with that minus acceleration it will decrease its velocity up to the highest point and will turn back. Okay, so from this point up until it reaches the 0 velocity value at the highest point, final velocity will be 0. Now it has a velocity of 300 minus 10 t dash. There it will take another 30 seconds. Okay, from the instant where the engine starts at the ground, first it took 30 seconds to reach the velocity value 300 meters per second, and then it takes another 10 seconds, another 30 seconds up to the highest point, completing that part under the motion of gravity. Okay, so the total time before turns back is equal to 60 seconds. So the total time before turning back equal to 60 seconds. What is the time? After what time from instant of firing from the beginning will the rocket attain maximum height? After 30 seconds. First 30 with the acceleration, second 30 with the motion under gravity. So the complete time until the highest point is 60 seconds. Okay, now let's see what's the time. Now it's 11:18. So let's start at 11:35. Let's start at 11:35, and I think you don't have a class in the evening. I think you don't have a class in the evening. If you have online class in the evening, you can leave after 12. Okay, I'll continue up to 12:15, 12:20. So this is the plan. I'm going to start projectile motion. I'm going to start projectile motion MCQs. Let's say until 12:30. Okay. If you have online class in the evening, you can leave. Let's start at 11:35. I'll add another link. I'll add the next link, and through that link we'll start. And from 11:35 to 12:30, we'll be discussing the MCQs from projectile motions. Okay, I'm starting at 11:35 with a new link.